So guys, today we will review system engineering for gate mining engineering. Okay, we have a very small syllabus in this chapter. The first one is first type of questions which generally comes is linear programming, and we have a graphical approach for that. We have different equations, and we have to maximize or minimize given condition such as this one, and we have conditions for that, and we can draw diagram or graph, and most probably the point of intersection which lie in the feasible region give the solution of the maximum value or minimum as per the conditions. Then we have assignment method. In assignment method we have a method called Hungarian assignment method, which I will show you its solution. See, there are given tasks and different groups which will do the task, and here it may be given the time, duration or cost of the task. Okay, so here what we can do is, the first step is to subtract the least value in that row. For example, here in this row we have 4, and we will subtract 4 from each of them. Okay, and likewise we will do the same in all the rows, and we will get a chart again, a table, and then what we will do is subtract the minimum in each column where 0 is not there, because if 0 is present then it is the minimum in that column. Okay, here we have 4 and here 1. We will subtract 4 from all the elements of this row and 1 from all the elements of this row. We will get this chart, okay, table. And now we will select 1 zeros from each row or column as per your choice. For example, first we will select this one, because we have only 1 0 here. We have selected this one, and we will cross all the other zeros present in that column or this row where this 0 was present, because we have selected 1. Okay, we will cancel these two. We will then get, see, here we have only 1 0 in this line, because this one is cancelled. Then we can select this one. All the zeros of this row will get cancelled, even if in this case it is not there. We can select now this one, because if we have selected this one, then we have to cancel this 0, this one, and in this line all other zeros must be cancelled. Okay, we have selected this one now, then we have to cancel this, and this one is the only one left. So we got our 4 elements, 1 2 3 4, and which represents 5. This 0 represents 5 and this 0 represents 4. So likewise 5 plus 4 plus 2 plus 7, and we got the answer 18. Done. And coming next, we have transportation problems. Okay, for transportation problem we have 3 methods. First we can use the linear programming by forming equations, and we can do, but we generally don't prefer that. For balanced conditions we have 3 methods. Balanced conditions mean the supply must be equal to demand. Okay, here we have supply, here demand, and the total of both of them should be same. 200 plus 100 plus 300 equal to 600, and here 150 plus 175 plus 275 equal to 600. Now we have 3 methods: northwest corner method, the minimum cell method, which is also known as the least cost method, and Vogel's approximation method, VAM. Okay, now the northwest corner method. In northwest corner method, what we do is we assign the amount we can assign in the most northwest corner cell. Like here we can assign 150, because the total supply is 150 here. Then all the other cells of this row cannot be assigned any value, then we will cancel that, And coming to next northwest corner method, this one is the next most northwest corner cell. Here we can fill 50. Okay, because total demand is 200, 150 we have filled earlier, and the left 150 we will fill it here. And now we cannot fill anything in this row, so we will give a dash here. Likewise, now this one is the most northwest corner cell. Okay, then we will fill here 100, because the demand is 100 and it can supply 175, and we still got 150 plus 100, 150. We have still got 25 left, so we will fill 25 here. Okay, and the rest 275 will be filled here, because it is the only cell left now. Done. नाउ मिनिमम सेल मेथड. अब मिनिमम सेल मेथड में क्या करेंगे ना हम लोग कि देखेंगे जो भी सेल में सबसे कम कॉस्ट लग रहा है, जैसे कि यहाँ पे 4 इज़ द लीस्ट एज़ कम्पेयर टू दीज वंस, लाइक 6, 7, 8, 11, 10, 11, then 4 is the least, then we will fill the 4 first with the most amount of value we can fill. Like here the demand is 200 and supply is 275, then maximum what we can fill here is 200, so we will fill here 200. Okay, and the left 75 will be filled here, because the second most least cell is 5 after 4, then we will fill 75 here. Okay, and third we will fill here, because we have 8. Okay, because the rest we these got cancelled, because we filled 200, which was the total demand of this row. So comparing these values, we have only the third one, which is the least and available, is 8, so we will fill 25 here. And likewise all the least cells are filled, and the answer comes here. Okay, now we have Vogel's approximation method. Okay, so here what we do is subtract the least values in a row. Okay, here we have 8 and 6. Okay, the two least, because 10 is greater than these two, so we subtract 8 minus 6 and we get 2. Likewise we do for the other rows. 11 minus 7, 4, and 5 minus 4, 1. And we do same for the columns, like here we have 4 and here 6. 6 minus 4, 2, 8 minus 5, 3, 11 minus 10, 1. So we get these values called as penalties, and the highest is this one, 4. So we will work in this row. Okay, and we will get the least in value in this row. We have 11 and 7, so we will first fill 7. Here demand is 200 and supply is 175, so we can fill 175 here, so we will fill 175 here, and left 25 will be filled here, because now we will cancel this row and work in these two columns, columns. So here again we have 2, and here we have 1, and in this we have 2 again we 8 minus 5, 3, and again here we have 12 minus 10, 2, and the highest value comes out to be 3. So 3 compared to the parentheses in row wise or column wise, we have the highest 3. Both will be compared, because 4 here is cancelled. We have used 4 once for this row, and this row is no longer exist, so we will use 3 and fill here 100, because the total demand here is for 100, and supply is 275, so maximum what we can fill here is 100, and the left 175 will be distributed in these two. We will see how. Now again this column is also used, because the total demand is 100, and which was used, so we will cancel this also. Now what we have left is see, this row and this column is cancelled, so what we have left? 6, 10, 4, 11. Okay, we will subtract 6 minus 4, sorry, 10 minus 6, we will get 4, and then 12 minus 4, we will get 8. So and likewise in column also, 6 minus 4, 2, and 12 minus 10, 2. So the maximum comes in this row. We got 12 minus 4, 8. Okay, and the least in this row is 4. See, there are two steps. First we will select the row or column, and then we will select the least value in that cell or in that row or column. Okay, and here we have 4. So what we can do is, we have filled 175 earlier here. Now we have left only with 25 for the demand, and we are available with 175, because 100 we have filled earlier here and 175 was left, so we can easily fill 25 here, and the rest amount is filled here. Okay, and here also we have fill 150, because all other are filled and we have only left with this row, so we can fill anyhow or what, because the condition left is 150 here, so 150 we have to fill it here, and 150 here, because the supply here is 150. Thank you. And now we have optimal solution. These were for the balanced case scenario, and even if it is asked for optimal solution in balanced case scenario, we have to use Modi method and stepping stone method. We will see later. Now we have critical path method. Okay, see, critical path method is a deterministic method, like we don't have to depend on probability. Is like the values are accurate and correct, but PUT is a probabilistic method. Okay, so the only thing which we do in critical path method is find a path which has the longest duration, or which the path which takes the longest duration for that particular work to be completed. Okay, so like here we have 9, 5, 11, 8, which results in 33, and but 9, 7, 11, 8 results in 35. So this path is the critical path, because it takes the longest duration to complete. And the slack, we have a term called slack value. Slack value means the activities which don't lie in the critical path has some slack value. For example, here the maximum duration taken is 35 days. Okay, and and the second path took only 33 days, so here the slack can be of 2 days. We can assign 2 days to some activity or task which is not in the critical path. For example, task A, C, D, E and F lie in the critical path, so we can't assign any slack. Here slack value is 0. But in task B we can say that the slack value can be of 2 days. The thing is, we can add slack value only that much that is does not exceed the critical path days. Like for example, here if it's 35, and in this part we get number of days equal to 33, then we can add only 2, which equalizes to 35. Now we have PUT method. In PUT method we have most probably only 3 things, which are, see, T naught, optimistic time, okay, Tm most likely time, and Tp pessimistic time, and the average of these three gives the expected time. But average is not T naught plus Tm plus Tb by 3. No, we have 1 times T naught, 4 times Tm plus 1 time Tp by 6, like here, and that gives us time expected time. Okay. And for a standard variation, what we do is we have 3 times, such as T naught, Tm, Tp. We subtract Tp with T naught and divide it by 6, we get the standard deviation. Now we get variance by squaring the standard deviation, we get variance. uh, do keep in mind, for any calculation in standard variation, first calculate variance and then take the root of it. For example, if there is a column of variance and a standard deviation is asked, then what we have to do is uh, eat, eat, add each value of variance, like uh, sigma square 1, sigma square 2, sigma square 3, sigma square 4, and then what we can do is take the under root of it, which gives standard variation, standard deviation. uh, and what see, like we have got Te here. After finding Te, what we can do is create a critical path method, create a critical path network in the PERT question and solve that. Okay, so I think this much is enough for today.